Today we're going to look at section 5.5b, synthetic division. Our objectives are to be able to divide polynomials using synthetic division, to be able to use synthetic division and the remainder theorem to evaluate polynomial expressions. So when should we use synthetic division? We only use it when we're dividing by a linear expression, and it's usually in the form of x minus a. Now we are going to be dealing with some problems that may be in the form of, say, bx minus a, where we have a coefficient in front of x other than 1. And you can actually, if you look on the web, there are actual ways to use synthetic division when it's non-linear. It's just a little bit more difficult, and if you're going to do that, you might as well just use long division like we did in 5.5a. But we're going to go through a couple examples after we talk about the difference between a factor and a zero. And this is going to be a really important distinction. So if you have a polynomial p of x, and if I have some value a, because remember this is our input, and it gives us an output of 0. Okay, then that a is called a 0, and the reason is because when I input it, my output is a 0. X minus a is called a factor, and we talked about it a little bit before going backwards. So if a is our 0, okay, x minus a is called a factor. And just as a side note, if a is a real number, then we can put a comma 0, our input and our output, as an x-intercept. If a is not real, if it's an imaginary answer, we can't call it an x-intercept. X-intercepts only deal with real terms. A is also called a solution or a root of p of x equals 0. And again, we get a solution when we solve and set it equal to 0. So those are some of the words we're going to talk about throughout this chapter: 0, factor, solution, root, and x-intercept. So let's go through a couple of examples. You're going to see that this is much easier than what we did with long division. So this is a problem that we would have had yesterday. 3x cubed minus 4x squared minus 10x plus 2 divided by the quantity x plus 2. Now in long division, we'd put this on the outside and put this inside our little divide symbol. Well, what we're going to talk about today is taking this, which may be a factor, but taking this binomial, okay, x plus 2, and let's solve it and see what actually x equals. So what's the 0 of this little binomial? That would be x equals negative 2. This is the number we use when we use synthetic division. And what synthetic division looks like, it's kind of like an upside down division symbol. We take this value and stick it on the outside, and inside, okay, are all of our coefficients, and they have to be in order, and we can't miss any. So if you look here, we have 3x cubes. I'm just going to label these the first time just so you can understand. I have negative 4x squareds. I have negative 10 x's. And my number at the end, I have 2. You will always need a number in each column, so it is extremely important that you use placeholders if you don't have a specific term. You can't have any gaps. In long division, you don't have to write it in. Synthetic, you do. And this is how synthetic division works. We always drop down our first term, so I'm going to drop down the 3. Negative 2 times 3 gives me a negative 6. And now we add. So if I add this, I get a negative 10. Okay. Negative 2 times negative 10 gives me a positive 20. I add to get a positive 10. Negative 2 times 10 is a negative 20. I add to get negative 18. So again, we drop down the first term, get a 3. You always take the outside terms and multiply, just like you did with long division. You write that term, but instead of long division where we had to subtract, the nice thing about synthetic is we can just add. And the reason we can do this addition is because when we solve this, we got a sign change, and that takes into account the subtraction. Again, multiply, add, multiply, add, multiply, add. So how does this help us? Well, this last number is always our remainder, and then we go backwards from there. We have our remainder, our numbers, our x's, and our x squareds. We should always get a term 1 less than what we started with because we're dividing by a linear function. So if I write my final answer, I'm going to get 3x squared minus 10x plus 10. And I always like to add, and then I just write my remainder over what I divided by, my x plus 2. And if you were to check, that's the same exact answer you get with long division, but much easier. So let's go through another example. I now have this polynomial divided by x minus 4. And again, hopefully you know that if I solve this for 0, set this equal to 0, x would be 4. Okay? So I'm going to draw my little synthetic division symbol. Now here I have x to the 4th And sometimes it's just nice to do this. Before you even look at the numbers, look at your largest degree, 4, x squared, x's, so 4, 3, 2, 1, and then no x's. And now I'm going to put in my coefficients. I have 1x to the fourth. I have 0x cubed, so it's really important that you put a placeholder there. I have negative 2x squared, negative 31x's, and a negative 4 for my constant, my number. So what I'm going to do first is I always drop down this first number and put a 1. And then from here I multiply. 4 times 1 is 4. Then I add. 0 plus 4 is 4. 4 times 4 is 16. Then I add, okay, and I'm going to get 14. 4 times 14 is 64. Okay. Then I'm going to add, which gives me 33, a positive 33. 4 times 33 should give me 132. I add, I get 128. And then I'm done. Okay, so again, drop it down. 4 times 1 is 4. Add, multiply, add, multiply, add. Just be careful with your signs. Okay. Multiply and then add. Again, this is my remainder. So what I like to do, instead of what your answer is going to be, is always 1 degree less than what the column is. But a lot of times people don't write that. So I always do remainder. I just do number, x, x squared, x cubed. And that'll help me write my final answer. So my final answer would be 1x cubed, or just x cubed, plus 4x squared, plus 14x, plus 33, plus my remainder of 128, all over what I divided by, which is x minus 4. Okay, and again, if I multiply this by this huge long polynomial, I should get back to what I started with. So let's look at a problem that's a little bit more difficult. 5x cubed plus 11x squared plus 26x plus 26 divided by, now here I changed it. I wrote 5x plus 6. Now this is a little bit different because it's not just an x plus 6. I have this coefficient other than 1 in front of the x. And what I did is I already wrote out what it would look like if we used our long division, just to kind of have an answer to compare it to, because this is something you should hopefully understand from our last lesson. What we're going to do is, there's a couple ways to do this with synthetic division. I'm going to try to show you the one that I think will give you the less mistakes, and hopefully it'll be the easiest to understand. So let's look at this problem again. So I'm going to look at this problem now, and this time I'm going to use synthetic division. So what I'm going to do is disregard the 5 for a second. And again, I'm just showing you one possible way to do this problem. There's more than one way to use synthetic division when you have problems that aren't in the x minus a form. But I'm going to show you the one I think is the easiest again. So I'm going to just pretend the 5 isn't there, and I have pretend like it's x plus 6. So then I'm going to put a negative 6 on the outside of my synthetic division symbol. And then I'm going to write in all my numbers. I have 5x cubed, 11x squared, 26x's, and 26 for my number. Okay. But I'm not going to completely forget about that. I'm going to put that 5 down here, and I'm actually going to do this. I'm going to divide by 5. Okay, so let's make that divide by 5. Okay, so let's go back and do this. I'm going to drop this down and get a 5. But before I multiply, I have to take this number and divide it by 5. So 5 divided by 5 is a 1. Now I'm going to do the same thing. Negative 6 times 1 is negative 6. If I add, I get 5. But 5 divided by 5 is 1. Negative 6 times 1 is negative 6. If I add, I get 20. But 20 divided by 5 is 4. Negative 6 times 4 is negative 24. And when I add, I get 2. Now the remainder you do not touch. Okay, this stays the remainder. We don't mess with the remainder. But how would I write this as an answer? Well, this is my remainder. These are my numbers, my x's, my x squareds. So let's write out this answer. If I look here, I get x squared plus x plus 4 plus my remainder is 2 over what did I originally divide by? 5x plus 6. So let's see if I can do a comparison to what I did the page before. If you look at the answer, x squared plus x plus 4 plus 2 over 5 plus 5x plus 6, I get the exact same answer. I had to do all this work with the long division. But if I take a linear function, I can just do this and divide by 5 at the end, and it actually ends up giving me the exact same answer. So it's just a way to deal with problems that are a little bit tougher. There are more than one ways to do this, but this is probably the cleanest and the easiest way. If you remember from long division, we had x squareds, x cubes. You can do this same method, but it does get more complicated. So I'm not going to show you how to do that, but if you are interested, you can always spend a little bit more time looking it up on the internet. But I will ask you on the test how to do problems with long division and some specifically with synthetic division. Okay, so we're also going to talk about the remainder theorem. What is the remainder theorem? Well, it's when the polynomial function f of x is divided by x minus a, which we've been dealing, the remainder is equal to whatever f of a is. So you might think, okay, what does that mean? So what this is saying is if I gave you a big problem, so you use synthetic division, and this remainder theorem is all with synthetic division, so make sure you remember that for the test. If I gave you some polynomials, so you had like 7, 0, -1, 2, 3, whatever it is, and we know if this says x minus a, that means I'm going to put a on the outside. After going through all this and filling all this in, this answer is my remainder. Okay, this is my remainder. Whatever answer I get here is my answer for f of a. So what they're saying is if I input into my function a, my output is always the remainder if I use synthetic division. Okay, so it equals the remainder. So let's go through a couple of problems so you can actually see how this works. But again, anytime I put an input, okay, the remainder is going to be my output, and that's what the remainder theorem says. So here's my function, 2x cubed minus 4x plus 13, and I want to know what we get when x equals 4. Now, earlier this year, we would have just done substitution. That is not what I want you to do for the test. If you do that alone, you will get 0 credit. I want you to use the remainder theorem. And again, the remainder theorem says, if I use synthetic division, and I take what my x equals, put my 4, my input on the outside, and I fill everything else in. So here's my x cubes. I have 0x squareds, -4x's, and 13 for my number. And I run through synthetic division. I drop down the 2. 4 times 2 is 8. Okay. This adds to 8. 4 times 8 is 32. Add, I get 28. Multiply here. Let's see. 2, 3, 8, 9, 10, 11. So 112. If I add this, I get 125. This is my remainder. Okay. So what this says is when I take this function and I input a 4, I should get an output of 125. Now you can double check this, and this is fine to do on the test. As long as I see this work, it is okay to do this. Okay, I know 2 times I'm inputting a 4 cubed minus 4 times inputting a 4 plus 13. This is 2 times 64 minus 16 plus 13. Okay, when I multiply this, I get 128 minus 16 plus 13. Okay, 112 plus 13. And there's my 125. This is what we used to do. The remainder theorem states, again, when I have my input, the remainder is my output. And this is the work I'd like to see on the test. So let's try another one. Okay, this I just wrote it a little bit differently. We know this is my input, the -2, so I'm going to put that on the outside. Okay, and all I'm going to do is try to find my remainder. I have 3x cubed, 8x squared, 5x's, and -7. I'm just going to go through the algebra. Here's a 3. -2 times 3 is -6. Add, I get 2. Multiply, I get -4. Add, I get 1. Multiply, I get -2. Add, I get -9. Again, just circling this alone isn't the answer. I want you to tell me that f of -2 equals -9. Okay, I actually need to see what the answer is. And you could, again, on the test, take your -2, substitute it in, and you should get a -9. But this is actually, I think, a much faster and easier way to do without a calculator. If I asked you to substitute -2 in without a calculator, a lot of you guys would have a hard time. But none of the math here was difficult. And the last thing we're going to look at is finding the missing factors. So what I gave you is the polynomial function, and I'm telling you it has a 0 at x equals -3. And remember, factoring, we spend a lot of time factoring this, but this is a way that if you know a 0, if you know one of the solutions, you can actually work backwards to find the factors. So let's kind of think about this. If I know x equals -3, what x equals goes on the outside of our synthetic division symbol. And then inside, again, I have 2, 11, 18, and 9. Drop down the 2, I get 2. And then from here, we just do the algebra. -6, add, I get 5. -15, add, I get 3. -9. Now, I got a 0. That is really, really good. That's why I put a smiley face, because it told me it was a 0. So if it's a 0, that better mean that the remainder is 0. So if you don't get a 0 here, that's going to be a big problem. So that makes me happy because I know I did it right. So because my remainder is 0, these are my numbers, my x's, and my x squareds. So now I know that when I substitute this in, this breaks down, because remember, this is like a division. If the 0 is x minus 3, that meant a factor was x plus 3. So right now I know if I was to factor this, I would get x plus 3 times something. And what that something is right here. 2x squared plus 5x plus 3. Now what I want to do is see, can I factor this anymore? So this is our trinomial. So this is just tying in what we've done before. So what I can do now is just factor this a little bit more. We can't lose any of our individual factors, so I have x plus 3. But if I was going to factor this, I know I need a 2x and an x. Okay? And I need to get a 5, so I'm going to put a 3 and a 1. Plus and plus. If I multiply this, I get 2x squared. Here's my 3. I have a 2x and a 3x. Give me my 5x. So all I gave you was the original. I gave you 1, 0, and what it did is it made it much, much easier to factor this as opposed to doing it all by hand. So these would be the missing factors. I hope you feel a little bit better about synthetic division, being able to use it to divide polynomials, and to use synthetic division when using the remainder theorem to evaluate polynomial expressions.